Okay, everybody. So thank you very much for coming. We got Kathleen Salazar, who's going to talk to us today and give us a little talk on some transportation concerns within within Colombia, and some of the research has been working on for quite a few years now. Because I've definitely seen the progression of this research over the last 3, 4, 5 years. Right? So yeah. So
Yes.
I really appreciate you coming today. And if you want to just put up your screen and take over, I'll hand it over to you.
Okay, thanks for inviting me. I'm really happy to be here with you all and share some of my work. So I'm gonna share my screen. Just give me 1 second, please. So now can you see my screen?
Yes.
Perfect. Okay, yeah, we will be talking today about urban transportation and how to represent the mode choices of urban travelers. And this is the outline that I have today. I will start with a little bit of background of about transportation modeling, and then I will present the motivation for this research. And after that, I will describe a little bit the process of this agent-based simulation model development. And after that, I will present some results of this application of the model for Cali City, which is a Colombian city, and finally some takeaways. So let's start. And in transportation field, we can differentiate two kind of models. Like we can talk about aggregate models and disaggregate models. And this is the most traditional approach. We have the four-step transportation model that aggregates.
We need to figure that out.
And so this analyzes aggregate traffic flow and aggregates users, like we have an average user that represents many users, and also aggregates geographic areas or zones. And this model focuses more on infrastructure development, like increasing capacity, for example. But right now, the interest for urban planners is more related to travel demand management. And maybe they are more interested in giving answers to questions like how to promote behavioral changes in urban travelers, or how to increase the public transportation use. And to give answers to these questions, it's necessary to have more disaggregation in the models and better representation of behavioral the behavior of these travelers. So we have then some options like the discrete choice models that are based on the random utility theory, where the users select from a set of alternatives. But these kind of models have a problem because they lack of interaction between individuals. So later on, with the advancements of computational aspects and the appearance of different tools, the microsimulation appeared, and that made it possible to have more disaggregate models at the point where that we can have now activity-based simulations or daily scheduled simulations. And with the need of understanding better behavior of these transport users and representing more realistic systems in the simulations, ABM has appeared like a very good approach to represent these interactions in the transportation system and the behavior of these users. Then we can say or define agent-based simulation in transportation as a microscopic representation of travel decisions of individuals who needs to move from one place to another while they interact with other travelers and also with the environment. And those decisions have impacts on the transportation system itself. So with this very brief background, now I want to talk about our research. What we wanted to analyze. So we had this interest in transport dynamics, and specifically in developing countries. And why in those places? Because most studies and most simulation models have been done in developed countries. And it turns out that the transport dynamics in those places differ from those in developing countries. If you're not familiar with it, let me show you this video. I can turn this off. Yeah. This is my neighborhood. What do this place have in common? There is hectic traffic, chaos, and many motorcycles. So as you can see, this is a very crazy condition of the mobility in these places. So we were interested in knowing how people make decisions about the transport modes, what factors influence that decision, and if through policy interventions we could influence those decisions, and in the end, what could be the impacts of these interventions in the system. And we thought that ABM could be a good approach to give answers to these questions. But before we start talking about the framework that we follow and the design of the model, it's very important to mention that these transport dynamics are different depending on the context. And there are some factors that influence these dynamics. For example, the environment, let's say infrastructure that is available, geography, climate, and also the culture influences the way that we move. For example, in the Netherlands, cycling is very popular, but in Colombia, motorcycles are more common. And also the characteristics of individuals, like socioeconomic or demographic characteristics. And there is also a very important thing, and that's perception about the transport attributes. And then, if we know that all of these things affect the transport dynamics, what are those in the developing countries? We have a very high reliance on motorcycles because they are low cost, fast commuting, and very convenient. And these kind of vehicles are concentrated in low and middle income classes that use these motorcycles not for touristic purposes like maybe it's common in North America. They use the motorcycles to commute from home to work. And this is also combined with a very low quality of public transportation services in terms of geographic coverage or frequency, capacity they have. And these factors have some negative impacts on the mobility. And then appear the high road accident rates, the health problems due to polluted air, and the traffic congestion that is just a waste of time. And having cleared those dynamics, so we decided to develop an agent-based model, but how to represent these dynamics. So we implemented a mixed approach using some qualitative tools with some quantitative analysis. Oh, sorry, the other way. And then we are using all of this information to feed the model. And on this slide, I want to show you the framework that we are following. We, as I mentioned, we applied some qualitative tools, and we started by conducting some focus groups because we wanted to understand how people think about the transport systems, and that helped us to better design a survey that we implemented in some Colombian cities. And this survey gave us inputs to determine the influencing factors in the mode choice. And then those factors were incorporated in the model as agent attributes. But also we needed information from the city, like census data, accident rates, the distribution of the fleet in the city, and that also affects the characteristics of the agent. And we also needed to describe the environment, in this case is the city, and things like distribution of neighborhoods and the location of the household and the workplaces are affecting also the behavior of the agents. And these agents interact with other people, so we also include social networks to connect these individuals in the model, and also needed to define the transport modes that we were analyzing. In this case, we selected private cars, motorcycles, and public transit. In the city where we are going to see results later, we have bus rapid transit, the BRT. And all of this is influencing the decision-making process. So we have to define the behavioral rules for these agents to be able to forecast the mode selection. And these outcomes have some impacts on the system, such as road accidents, CO2 emissions, and traffic congestion. So this is like the general framework that we follow to try to capture all these cultural, socioeconomics, and demographics that we know that are affecting the transport dynamics in the city. And now here we have the representation of the transportation system, where we define a decision module for the agents. And we also have some policy interventions, like improving infrastructure or improving the public transportation service or having market regulations. This changes the status of the system, and that also influences in the decision making of the agent. So we have or individuals start simulation with one of the three options they have. They commute from home to work or school, and after the trip, people calculate satisfaction obtained with the transportation mode they use, and also accumulate experience. With this information, they evaluate their mental model and either repeat the same mode or change for another one, and so on. So these interventions here can influence in the satisfaction of agents, ending up in a different selection of mode. So basically, this is the way the model works. Now, this mental model is applying the consumer approach, which is a framework that integrates different consumer behavior theories that was proposed by Jaeger and Jensen in 2012. And they say that people can follow different strategies to make decisions, and they evaluate the decision based on the satisfaction with the current alternative. This satisfaction in this case is a function of these attributes or transport variables that we are considering in the calculation, and also people evaluate uncertainty regarding the other alternatives. In this case, we are defining uncertainty like the information they have. And after the calculation of these two values, agents compare against thresholds, and based on that comparison, they are divided into different decision-maker groups. So people can repeat, imitate, deliberate, or inquire, like a comparison with others in their social network. And these two groups here are making more individual decisions, while these two groups here are going for social engagement to deal better with the uncertainty that they are experiencing. For those going to gather information with their peers in the social network, we are implemented then a social network in the model to connect people. And we use the preferential attachment network that connects people in the same socioeconomic class with a higher probability. And then with the small world concept, we are wiring some people in the rest of the city. And here we have an example of the network for Cali City, where we have a very high concentration in middle income classes. And then this is the way that people in the model connect to gather information. With this model, we are then contributing with an agent-based model that is also including or incorporating the social influence in the decision-making. And very important is that we are including motorcycles as a full transportation mode that we already know are very important in these developing countries. And with results from this research, we are helping to close gaps in knowledge about transport dynamics in the global south. And this information is useful also for policymakers to devise better strategies or interventions directed to the different kind of travelers that we have in the city based on their behaviors and preferences. And ultimately, this methodology could be replicable and it can be extended to other contexts beyond the developing countries. So it's useful for other kind of cities. Now, I will show you some results from Cali City, which was selected as our case study, just to give you some context in case you don't know where is it. Here is Colombia in South America, and this is the state in the western part of the country, and this is the urban area that we are looking at. Cali has 2.3 million people, and these people are concentrated in low and middle income classes. And here we have a very big participation of motorcycles in the total fleet in the city that every day move about 1 million passengers. And also this city has a very high road accident rate. And that's why we thought it was a very interesting case study to analyze this typical transport dynamics of developing countries. About the parameterization of the model, we had to define attributes for transport users, and we have some demographics like age, gender, or socioeconomic status. We needed to define also the technical characteristics of transport modes, things like emissions, fuel efficiency, and initial speed, and so on. And also the environment, in this case, is the city, has some attributes that we needed to include in the model. And here we have different sources of information to parameterize these variables, but one that is very important for us is the survey that we designed and implemented in the city. And this questionnaire includes some demographic characteristics to describe the transport users. also has some travel behavior characteristics to know how people move and basically trip variables. And also it's very important to know about perceptions they have towards the transport attributes. And on this QR code, we have an interactive dashboard that summarizes the results from this survey in case you want to check it out later. Well, how are we using this survey data? We first validate the significance of the variables that we, based on the literature review, know that influence the decision making in the case of the mode choice. And after validating this, we included these variables in a multinomial logic model, and that helped us to define those attributes for agents in the model. But also, based on this logic model, we calculated the odds ratios based on the estimates, and this is being used as the probability for those deliberators, the decision group, the decision maker group that is deliberating in the model is selecting the transport mode by probabilistic distribution, and then we are using those probabilities from the multinomial model. Also, we wanted to know if perceptions were different between the social classes. Then we applied some statistical tests that allow us to conclude that there are indeed differences. For example, people in high-income classes think that security or comfort are very important, but people in the low classes place more important in things like cost. Then we are differentiating the weights or the levels of importance of these variables in the model to calculate the satisfaction function. If you want to have more details about the parameterization, we have this paper that was presented at the last winter simulation conference, where you can find like more information about it. Now, the experiments that we run in the city, we simulated 10 years. We developed this model in NetLogo, and this model was validated using the validation in part technique that says that we need to analyze inputs, processes, and outputs, and we compare against historical data from the city before the pandemic. And also we did cross-validation with the diffusion curve of products or services based on the BELS model. And in the simulation, we are tracking some indicators over the steps, like the distribution of transport modes, CO2 emissions, travel speed, and accident rates. Now, what we got for the base case scenario is that if non-policy or change is introduced into the system in the next years, in about 10 years, we will have a big number of private cars, which is this red line, and motorcycles, and we will have a decrease of in numbers of public transit users, which is something that is happening in the real system even before the pandemic. We are experiencing a decrease of these users, and that will exacerbate even more the problems that we already have in our mobility, because it will add up about 20,000 more motorcycles and 100,000 more vehicles in circulation. And after this base case scenario, we introduced some changes in the model, and we wanted to see different interventions, how they impact on the system. And for example, we were taking the public transit for free, the increased frequency, or the improved perceived security perception while using the buses. And we found that some of them have some better impacts in keeping people or avoiding that they migrate from the public transit to the private options. And then we started combining some of these interventions and found that some of them were more effective to keep people using the public transit. And after this, we analyzed different combinations and defined 4 policies. So we wanted to see which of these interventions were contributing to promote the public transit use or reduce emissions or accidents or congestion. Then we selected those 3 that were having higher impacts. And here we have the summary of these policies. And for example, for the first combination, we have the fare free, the frequency, and security all together. And we could have some positive impacts, such as the CO2 reduction of almost 5% per year, 14% decrease in road accidents. And in this case, none of the interventions had a positive impact on traffic congestion. And we are using, in this case, speed travel in the system for this as a proxy for traffic congestion, and none of these interventions were effective in that sense. In this case, more people were using the public transportation, which has a lower speed of travel, and as an average, that decreases the whole speed in the system. Going back to those research questions, what factors then influence the transport mode choices in these developing countries? So we could validate that culture, socioeconomic, and demographic aspects are having a strong impact on the mode selection. And for the specific case of Cali City, we have that age, gender, socioeconomic, and also perceptions about the transport attributes have significantly influence in this mode choice. And also, we analyze that social networks influences the way that people gather information and in turn affect the decision making. Regarding the emerging behaviors that we observe, we could see for Cali City that people were migrating from public options to private alternatives like car and motorcycle. And this could be explained by the long travel times and low security perception that people have about the public transit service. And motorcycles are very attractive because they are low cost, they have short travel times, and people don't care about the road accidents, which is a very high rate for motorcycles. And in the case of cars, for people in the high class income, they are preferring this kind of transportation mode because of the comfort and security that they provide them. And finally, we could see that these interventions that we take in the model had positive impacts in terms of CO2 reduction, CO2 emission reduction, road accidents reduction, and public transit use that increased. And we also could see that these interventions, when they are applied independently, they could have some positive impact, but still not a very big change in travel behavior. then if we combine interventions aimed at affecting multiple factors, we could have better results. And that's explained that the similar importance that users place in the different attributes, that's for the specific case of Cali. Maybe in a different city, results could be different. But these results makes it more difficult for policymakers to devise better strategies, because they need to find what are those that are having better impacts, and with a cost-benefit analysis, what are better to invest in. So finally, to conclude about this research, we could demonstrate with this simulation model that we developed that is able to represent the real behavior of the system, and that is also useful to analyze policy impacts. And then this could be used to try different interventions, but also that could be applied in a different place, not only in developing countries. That methodology could be replicated and applied in contexts beyond the developing countries. We continue working on this. What we are doing right now is that we are incorporating geographic information in collaboration with George Mason University. We are improving the representation of the city and distribution of neighborhoods, and that give us the possibility to explore a wider, more options for policies, right? Like things related with the spatial distribution. And also, we want to analyze policies with a gender focus, because we implemented a second version of the questionnaire where we included some gender-based questions, and then we can analyze these impacts on of policies on the mobility with these gender differences. And maybe I have a short video of the model is looking like now that we are implementing the GIS too. And I think that's all I wanted to share with you today. I'm open to questions, comments.
Thank you very much. Thank you very much for that talk. So the way we could do this is, I suggest that if anybody wants to stick the hand up, or if anybody's got a question to ask, feel free to just jump in. I have a question. This is one that takes advantage of the fact that I know your research a little bit better. One of the most fascinating things that I found when you previously talked about your research was how women would prefer to use the motorcycles over the buses. Is there any chance you could just talk about that and why that's occurring, and why there's more of a large female demographic that uses the motorcycles?
Yes, that's a very interesting thing that we found when we started talking to people and also analyzing results from the survey. That one of the main reasons for women to change their mode was the security perception. And they felt, well, in general, and many studies in different places show that women usually feel more vulnerable than men. But in this case, the difference between cars and motorcycles is huge. Like, they feel really, really insecure in the public transit service. And this phenomenon started maybe in the last 5-8 years. The number of women that are using motorcycles increased. Like the share was about 16%, and now it's about 33% of women. So that's increasing, and they are migrating mainly because of this sensation of insecurity. And Cali is one of the cities. It has appeared in different rankings for being one of the most dangerous cities in the world. And crime and murders, robberies, many different things are happening in the transportation system. So that's why women feel better using a motorcycle, even though this is very dangerous, let's say risky mode, because it has a very high accident rate. And people, it's funny because when we analyze the level of importance to the different variables, that's the least important. Like, they don't care about road accidents, and we have a very, very high rate. Like last year, we had about 8,000 million deaths related to traffic accidents. So that's a big number for.
So how many deaths was that? Because I think you cut out slightly when you said it. How many deaths do you think you had due to accidents last year?
8,000. And in Colombia,
wow.
like in the whole country, yes.
Oh, okay, wow. Okay. That's
But
still a lot.
no, sorry, not in the city, in the whole country. But it's a very high rate if we compare with the population. We are a 52 million people country. So if we compare these numbers against US or Europe, it's a very high number.
Thank you. There is a question. There's a couple of questions in the chat. Unfortunately, someone's asked the question. Angela's asked the question in Spanish, and my Spanish is much worse than I barely speak English, so I have to defer to you to translate.
Okay. Someone is asking if maybe it's necessary to include other kind of variables in the model. Well, that's a good question. Yeah, we started with those factors that were reported in the literature as influencing factors in the decision making, right? Like those factors that I mentioned at the beginning, like things related to infrastructure or sociodemographics and culture. So yeah, I think could be useful to include other variables that maybe will help to represent better those characteristics of the city or country or the geographic area that we want to analyze. I think this is like a first attempt to represent that. As far as we know, there are not many models analyzing this kind of transport mode selections using agent-based modeling. That there are many models out there using discrete choice models, which is like the more traditional approach to analyze this kind of problems. But one thing is that we found many of the studies were applied in universities in developed countries. So this is like the first model that we know so far is trying to do it as a city level. And for sure, maybe if we explore other contexts, we could find other variables that are important to reflect that behavior of travelers. So which kind of variables, that is hard to say right now, but we were trying to include all of these that we found based on the focus groups and the survey and other studies. So yeah, thanks for the question, Angela.
Thank you. I think Matt's got a question. He's kind of put his hand up.
Yeah, sorry, I will now put my hand down. Very interesting talk. So thank you, just in general. You had a tantalizing bullet on one of your slides about validation by parts. I'd love to hear a little bit more detail about what that means to you and how you've executed it and that kind of thing.
Okay, thanks, Matty, for the question. Yes, this is a technique proposed by Kathleen Carley. So she has a tutorial on it, and it says that we need to validate inputs, like ensuring that we are using the right variables to put in the model, and also that the parameterization is important. Then in the processes, that means that we need to verify and validate how the code is built and how we are connecting variables. And in that part, it's suggested to do many of these techniques that are indicated in different books or handouts. And for example, we use the extreme values or sensitivity analysis. And then we started analyzing how the parameters were having impacts on the final outcomes. For example, the satisfaction and uncertainty thresholds were some of the parameters that we need to calibrate by sensitivity analysis. And we were analyzing how many runs in the model we need to decrease the variation or the deviation in results. And we ended up with 80 runs to have that coefficient of variation that we consider it wasn't high, right? And the other validation that we did was the cross-validation with the best model that is forecasting the numbers of motorcycles and cars in the city based on the historical data that we had. So maybe that explains a little bit that process.
Oh yeah, no, thank you. That was super helpful. And it's I don't know. There are, just as an anecdote, there was one simulation we were doing the same thing, trying to understand how many times do we need to run this to get a sense of central tendency and all that. And it came out to like 50,000 runs per parameter combination. Okay, what's our second guess? 80 is so much more reasonable. Really so fascinating work. Thank you again.
Thanks. I think there is another question in the chat in Spanish too, but no, it was a comment. Yeah, it was another question.
Excellent. So thank you very much. Are there any other questions from anybody? Don't be shy. So, we've got Max. Max has got a question for you.
Hello, Max.
Hello. Just a quick question about your data gathering. You know, it seems like that's one of the big challenges today, just kind of finding the right places and the right sources for your data, especially with developing countries. Can you tell us a little bit more about your challenges with some of that?
Thanks for asking. Because it has been a nightmare. It's very difficult to get access to data. Like, it's supposed to be open public data, but when you go to the official websites, the link is not working, the files are not there, or everything is not updated. And so we have to send official requirements for the information, and sometimes we need to wait for months to get information, and then when finally comes, it's not what we asked for. So it's been a process, as Andy mentioned before. I've been working on this like the last 4 or 5 years. So it's very important to get close to the public entities, because unfortunately, following the regular process doesn't work. Like, we need to have someone inside that help us to accelerate the process a little bit. So that has been very challenging. We don't have like this culture of data, open data in our countries yet. And one of the like why we had to implement that survey by our own is because some of these variables that we knew that were important to include in the model were not out there in any of the databases, or some of the surveys that cities implement, the origin destination surveys that we use in our countries, sometimes they don't include some variables such as perceptions, for example. And also, for the specific case of Cali, the last origin destination was implemented 10 years ago. So that is very old, let's say, if we consider that this is a city that is growing and the transport dynamics have changed a lot in the last 10 years, because we have new neighborhoods, and we had the BRT now that was just starting when they implemented the survey. And that's why we have to do this big effort in field work, gathering information by our own.
Since you've done so much work already with it, field work, will you make the results available, or are they available now for other people to look at and maybe use in their own simulations?
We have these Tableau dashboards where you can see the results and filter different variables to have that idea of this information. We don't have the data sets available, but if someone wants to use it, can reach me out.
Thank you.
I think we got Tom's got a question.
Yes, so this is just like an expansion of the question that Max asked, but just out of curiosity, and I appreciate it costs money and can't give some of the more kind of perception-based stuff, but did you guys look at trying to acquire like any like the cell phone data, where it might be able to give you, gender and origin destination information, stuff like that, in a kind of like more real-time fashion, or is that just off the table?
The answer to that is cost. Like here is not like we have an open data set from these cell phone companies. We will have to pay for that, and that will be a little bit expensive. So I know that some projects are running in Bogota, but they are being led by the government, so they are paying for that data to analyze some of these transport dynamics in the city. So yeah, we try to explore that at the beginning, but the problem is just funding.
That's always the problem. All right, thank you very much. A great presentation.
Thanks.
Excellent. So, well, thank you very much. Really appreciated your talk today. That was excellent. So I think that's very enjoyable. So clap around.